The arrow of time is forever pointing forward. The entropy and randomness of the universe keeps increasing to an inevitable heat death. The cosmic laws almost seem to have a preference towards moving forwards in time. But is there really anything that causes time to move forward indefinitely? Are we truly bound to this motion forever, or will we someday find a way to possibly rewrite our own history? Time is often considered the fourth dimension, and we've covered that notion in a dedicated video that's worth watching up here or else linked in the description. But that isn't all there is to time. Time is far more intricate than any simple explanation that can be given. It is a dynamic concept that depends on the individual who is experiencing it. Time always ticks forward for every observer in the known universe till now, but the rate at which it ticks changes based on the location and the speed of the observers. Describing time without using time itself is a Herculean feat. Time is that property that allows for changes to take place in the universe. It's what determines the length that one would have to wait between two distinct events. However, unlike separations in space, separations in time cannot be traversed at will. It's possible for you to travel between two unique points in space named A and B as many times as you want, A to B and back to A before traveling to B yet again. Yet, if there are two distinct points in time, namely C and D, you will reach them once and only once, and you cannot decide or choose which event you will reach first. It's like it's already determined, and the only control you have is how fast you travel from point C to point D when compared to someone else measuring the time it takes for you to go from one to another. The natural question arises as to why we can't simply traverse back to a point that we already visited in time, and if there's anything in physics that prevents us from fundamentally doing so. That's why today we'll solely focus on that property of time, which forces the universe to always gradually strive into the inevitable future. The direction of time cannot be discussed without the help of entropy. In our day-to-day lives, we can distinguish the past from the present and the future by our memories and our progress. We can tell if a video is being played in real time or in reverse by noticing a few key features. The main one subconsciously being the change or increase in entropy. When colors mix, they do not unmix. When a glass shatters, it never joins back. We see the universe shift from a specialized state to a more haphazard version of itself, with ever-increasing randomness in place of its order, implying that the entropy of the universe is forever increasing as long as time runs forward. In other words, we can tell if time is running forwards or backwards by analyzing if the entropy of the universe is increasing or decreasing. This property is often called the second law of thermodynamics. However, this law is not absolute, but only a result of statistics and probability. When a ball is dropped, it does not bounce back to its original height, as some of the energy is lost as sound and heat on hitting the floor. All of these energies are dissipated in the form of waves, in a way. When the video is played in reverse, we can tell that it's been reversed as the ball reaches a greater height after the bounce. However, this is still following all the laws of physics perfectly. If we were to have actually dropped the ball from a lower height while also sending all the heat and sound waves back perfectly in reverse, the energies would be added to the ball, resulting in this very motion. However, it is impossibly unlikely that sound waves, heat energy, and so on would all perfectly have matched up at the exact right time and place to ever add energy to the ball. But that does not necessarily mean that it's impossible. If every force was accounted for and every force was reversed, everything would work flawlessly while following all the laws of the universe. This means that there is always a vanishingly small chance of spontaneous order to emerge from randomness. Although very unlikely, it is possible for all the air molecules with greater energies to clump up in one portion of the room while the low-energy cold air clumps up in another portion, creating a momentary decrease in the overall entropy of the universe. So although the second law of thermodynamics prevents the universe from traversing back into the past, we should note that this law is derived from the fact that time always moves forward, and is a statistical view of how entropy develops in the universe. If time was to be in reverse, our laws would have changed accordingly, and nothing in the universe inherently prevents us from traversing time in other methods. The flow of time makes sense on macro scales, where we can see the effects of entropy increase. However, down in the quantum scale, individual particles do not necessarily experience time the same way we do. There are two core reasons for this. Firstly, most quantum objects travel at relativistic speeds, at a fraction of the speed of light, and hence have time dilated far beyond the dilations we experience here on Earth. Certain objects like photons travel at the cosmic speed limit itself and hence do not experience time at all. From the birth of a photon in a star till it's absorbed, it does not experience the movement. The second reason that quantum objects must experience time differently is because they do not experience entropy similar to the way we do. They are solely governed by the Schrödinger wave equation, and every individual particle behaves independently. So if a sample size of just a few hundred quantum particles was considered, then we would regularly find situations where there is a spontaneous decrease in entropy. It's only on the macro scales that entropy tends to increase, but no such restrictions occurs within the quantum scale. Since the forward arrow of time was being defined by the increase in entropy, that forward arrow of time, oddly enough, becomes far harder to distinguish for these quantum objects. This led to scientists studying the effects of reversing time for these fundamental particles, which showed that antimatter is the same as regular matter, just moving backwards in time with an opposite charge. So it is theoretically possible that antimatter is truly moving backwards in time, and had we been made of antimatter instead of regular matter, we too would have been traveling in reverse with an ever-decreasing entropy. We see the universe steaming with regular matter and very little antimatter. This could very well explain why we statistically always see an increase in entropy in our universe. So it might very well be that in the quantum realm, particles can travel in both directions of time at different paces, like any other degree of freedom. Despite the conversation about how nothing in physics prevents us from traversing back in time, one sacred property of the universe appears to be the deal breaker. Causality is the relationship between cause and effect and is the true cosmic speed limit. The effect created by a cause can be felt no faster than the speed of light in vacuum. This remains the reason as to why we cannot travel faster than light, and breaking it would cause various paradoxes. In fact, traveling faster than light in a way would allow us to traverse into the past. If we were able to traverse into the past, then any effect we cause in the past would be caused due to a cause in the future, which would break causality. If that seemed a bit confusing, let's try to draw it out. Imagine you scored a goal here in a mystical way that you didn't understand while scoring the goal. As time moved forward, you traveled to the past to reach the point just before you scored the goal and helped yourself score the goal. The effect was the scoring of the goal, but the cause of the effect was you from the future. Even though you traveled into the past, it still is your future. So essentially, the effect of the cause was felt even before the cause occurred, which clearly violates causality. These issues could maybe be avoided if timelines worked differently, breaking into parallel branches, self-contained loops, and so on. But these cannot be tested for now and hence remain as fictional constructs. Even then, in the case of self-contained loops or parallel timelines, can we truly consider that as traveling back in time? It seems a lot like your past was just in your future, and you still remain without control, and you still are forever traversing into your future, and time is itself moving forward only. The case would be different if your actions in the past affected your current timeline, and you yourself were to feel the effects of what you changed in the past. However, that does cause a lot of paradoxes, and we do not know if science can ever resolve these paradoxes, implying that it might just be impossible to do. Are these problems which we could overcome as further research into physics is completed? Could a theory of everything explain how quantum objects can traverse in time in ways different from us? Or will the theory just explain why that isn't how things work and tell us that time will never be traversed at will? We'll just have to wait to find out, while continually trying to probe for the truth, as and when we can, in our definite future. This video was meant to have more people start thinking about the flow of time and questioning observations to gain a better understanding of the world around them. There is much more that cannot be covered in a single video, like time dilation and how time itself might be slowing down instead of the universe expanding. We'll slowly cover those topics as well, but be sure to check out this video on time till then. While you wait, be sure to subscribe and like this video. As usual, thanks for watching, stay tuned, and stay curious.